What I want to do next is let's look at, again, another second order linear non-homogeneous with constant coefficients. And we have y double prime minus 6y prime plus 8y equals 5 sine of x. And so what we're going to do is we're going to look at and solve the complementary solution. To do that, we're going to be led to the characteristic equation r squared minus 6r plus 8 equals 0. That tells us that our solutions are going to be r equals 2 and 4, and therefore our complementary solution will be c1 e to the 2x plus c2 e to the 4x. Okay, and that's it for the complementary solution. Then we have to find a particular solution, and we have a constant times sine of x, so we should guess that our particular solution is going to be a constant times sine of x. And if we do that, then our particular solution's derivative will be a cosine of x, and the second derivative of the particular solution is negative a sine of x. And so if we plug this in to our equation, what's going to happen is we're going to get, remember when I say plug this in, what I mean is we're going to go up to our differential equation, and we're going to replace all the y's with y sub p's, the particular solution. So we're going to replace the second derivative for y double prime. So this tells us that our equation, which let's call it star, so star is going to become negative a sine of x minus 6 times y prime. So the derivative of the particular solution is a times cosine of x. So this will be negative 6a cosine of x plus 8 times y plus 8 times a sine of x. And then we want all of this to be equal to 5 sine of x. Well, we're going to have a problem because on the one hand, the negative a and the plus 8a is going to give us 7a. And so that could tell us that a is going to be 5/7. On the other hand, we want a to be 0 because we don't want any cosine terms to appear. There are no cosine terms over here. Okay, so there's no terms over here for cosine. So what this tells us is that we made the wrong guess. And it turns out what we need to do is basically just repeat what we did, but amend our guess for the particular solution. And so it turns out that since the reason why sine and cosine would appear in your solution is if you had a homogeneous equation and you had sine and cosine appear in your solution, that would be because you had complex roots, and complex roots always come in pairs. So whenever there's a sine, there's a cosine. So that means that when you're guessing your particular solution and the non-homogeneous part of the equation has a sine or a cosine, then you should put the corresponding other trig term there. So in our case, our differential equation had just the sine term. That means that we should also include a cosine term. So we're going to guess that our particular solution is a sine of x plus b cosine of x. And now let's check to see if that works. So we're going to proceed just like before. We're going to take the first derivative. So this will be a cosine of x minus b sine of x. And the second derivative. The second derivative is going to be negative a sine of x, negative b cosine of x. And we're going to plug those back into our differential equation star, which said that we had the second derivative. Let me just rewrite this so that we can see everything on the screen here. So the equation that we started with was y double prime minus 6y prime plus 8y equals 5 sine of x. Okay, and so when we do this, if we plug everything in, we're going to end up with, let's see, the second derivative is negative a sine of x minus b cosine of x minus 6 times the first derivative, which was a cosine of x minus b sine of x, plus 8 times our particular solution, which was a sine of x plus b cosine of x. I'm out of room here. And we want that to be equal to 5 sine of x. So what we can do now is we can group all of the sine and cosine terms together. And so this is going to tell us that we're going to have, if we group all the sine of x terms, we're going to end up with negative a plus 6b plus 8a sine of x plus, let's look at the other one. Let me write a little bit more compactly here. Plus, let's look at the cosine terms. For cosine terms, we're going to have minus b minus 6a plus 8b cosine x. And we want this to be equal to 5 times sine of x. Now notice that when the left side and the right side are equal, what we want to do is we want to find the constants a and b so that the left side and the right side are equal, meaning that we want to figure out when this constant is going to be 5, because we want 5 sine of x on the other side of the equation. And then we want this constant, the minus b minus 6a plus 8b, we want that to be 0. So now we have to solve a system of 2 equations and 2 unknowns. We want negative a plus 6b plus 8a to be 5. And we want negative b minus 6a plus 8b to be 0. Okay. And so, of course, we can simplify, and let's start there. So the top equation is going to end up being 7a plus 6b equals 5. The bottom equation is going to end up being, let's see, negative 6a plus 7b equals 0. And so now do whatever method you want to do. If you want to do elimination by addition, if you want to put this in a matrix, if you want to do substitution, anything is fine. I think substitution is actually the easiest here because this last equation tells you that 6a is going to equal 7b, and therefore b is going to be 6/7 a. And if that's the case, then the first equation is going to be 7a plus 6b, b being 6/7 a. That's going to be equal to 5. And now we can solve for a. So now we're going to end up with, let's see, so this is 49/7 plus 36/7 a equals 35/7, just to put everything in terms of sevenths. And then 49 plus 36 is a number that I really have to think about. 50, so it's 50 plus 35, so 85. So this tells us that A is going to be 35 over 85, and then we can factor out a 5 from each of these. So this will be 7 over 17. And if A is 7 over 17, then B is going to be 6/7 of that. So that'll be 6 over 17. And then finally what this tells us is that we have our particular solution. Y sub p is going to be a sine of x, so 7/17 sine of x, plus b cosine of x, so 6/17 cosine of x. And then once we have our particular solution, then we'll have our general solution. So our general solution we found is our complementary solution, c1e to the 2x plus c2e to the 4x, plus the particular solution, 7 over 17 sine of x, plus 6 over 17 cosine of x.